So this is the schematic. Here we can see that there is the mini USB cable where you can use it for powering up your circuit. You can see that we are only using the 5 volt and the GND. So the circuit goes inside this power management unit, which take care about recharging the battery and switching between wired on or battery powered mode. This one will do it automatically without resetting the circuit. So if you unplug it, it will automatically switch to the battery. So also here you have a button for switching on and off the circuit. It is important to notice that when it's power plugged, you will have this feedback here on this transistor, which basically will avoid to shut down the circuit when it's battery powered. And this is because if we shut down the circuit, it will basically, what it does, it disconnect the battery, so will not be recharge the battery. So this is why actually we have to keep the circuit on. Also, you will have these two resistors here, these two LEDs here for checking the status. One, it tell you if the battery is charging or not, and the other one, it will let's say tell you if there is a valid power source attached to the circuit. So the battery here used is a 3.7 volt lithium battery. That's what actually we in general use. The output of the circuit goes inside the low dropout regulator for lowering down from 3.7 volt to 3.3 volt. And from here we can use it for powering up all our circuit. This is the main microcontroller, is the STM32 L151. It's 32-bit, and here we attached a small temperature sensors on the I2C1 line. So including we also include the pull-up resistor. So you have two LEDs where you can control it by the pin B5 and PA7. So you can use it for blinking and for checking, and they are active low. We also included a way for sensing the battery voltage. If you need, so you basically there are, by using the pin PA4 and PA5, with PA5 you enable the sensing, and this one will basically charge a capacitor here, and then you can sense the voltages with Vsense. So, and by doing this one you can use it for checking if you have to recharge your battery or send an alarm, or doing whatever. Also, this is a reset button. And then we will start to talk about the connectors, which are, we have 4 connectors here. All of them are important. So the first one is the digital connector. So basically we have this I2C2 bus, basically the second I2C bus that we have on board of the STA. And plus we have 2 GPIO pin. And then we have VCC and GND, so on this connector. So you can use this one for attaching your digital sensor here. The other connector is analog connector. We have routed out the pins from PA0 to PA3 plus the GND and VCC. So these are general purpose input output, so you can use it both for controlling for reading, analog reading, or to write down something digitally, or so on this one there is also the analog to digital converter, so you can use it for converting your analog signals. Then the third connector is the RF connector. This is the connector which basically goes from one board to the other board, to the RF shield. And you can see that it's using a normal UART connection, UART protocol. So, and plus we are using other pins like a ref config here, which is basically here it's connected to B15. This is for configuring registers inside modules. If you want to know more about that, you should read the datasheet of the Radiocraft. Plus we have routed also several GPIOs pin in case that you want to use interrupt or you want to communicate something your more advanced things, because you will discover that these modules can do a lot. So just read the datasheet and you will see that actually there are some uses to for these pins too. So but anyway, this connector you will basically not use it. You can use it for debugging if you want it, for example, attaching something on this UART and see what actually the microcontroller is sending or what is you receiving. But in general, this when the board is mounted, you will not see any signals going through because this is used as communication between the two boards. So, but the last and the most important connector is the main connector here, how we call it, and this is used for programming the board by using the SW-EO and SW clock signals. You can use this kind of JTAG, but it's from a single wire is called debugger, and so, and by using this one, you can flash the code inside the microcontroller. And we'll in a later video we'll show also how. In particular, you will need to use. We advise that you can use just a normal discovery board, ST discovery board, and you can use it as a flashing board. And also we rooted out the first I2C bus, the same which is attached to the temperature sensor. We also rooted out here, so you can debug it or check it or even use it in case of emergency, and so on. Someone noticed that we didn't root any, say, okay, what if I need SPI or what if I need UART? Well, I advise that you actually check, because there are many of these pins that we rooted out here. They actually have a secondary functions which can be used as a UART or as a SPI. So just read the datasheet and see if you can actually reuse. Let's say don't use any analog pin and just use the UART or doing this. You should double check with the datasheet because there is this opportunity. Well, this was an overview about the board, and yeah, I hope that this was useful, and thank you for watching, and see you at the next video.